Today we're going to look at the graph of the parent cosine function. We want to see what changes happen there, what the parent function looks like, and how the unit circle affects what this graph looks like. So here is just one period of the parent function for cosine. So we would say it's y equals the cosine of x. The same thing's going on here. X are angle measures. Input values are all those angle measures around the unit circle. They lead to corresponding output values around the unit circle. So now we have all of these XY points that we can plot in the plane. And we know that cosine is, again, a smooth continuous function. It has in its period only one minimum, but it has two maximum points. There's a maximum point and here's a maximum point. We can see the amplitude for the parent cosine function is 1. So the amplitude for the parent cosine function is 1. And the period for the parent cosine function is 2 pi, because it does from 0 to 2 pi. It goes around that unit circle just like the sine function did, and it maps out just like this. So it kind of looks like a piece of the sine function, and they are really they are related to one another. The more we get into sine and cosine, the more we'll see the relation between them. But let's map from the let me see if I can move this. Let's map from the unit circle just like we did for sine. So when we start at an angle measure of 0, the output is 1, so that's why the very first output value is here at 1, and then you can see that it goes all the way around that unit circle and maps all the way back to 2 pi. It is a continuous function just like sine is, where sine had a 0 here and at 2 pi. Cosine has a 0 at pi over 2 and 3 pi over 2. So you can see straight from the unit circle that we are getting the graph of y equals cosine of x based on all of those values around the unit circle. So let's go back and look at what's happening with the parent cosine function. So here are all the interesting things that we need to know about the parent cosine function. The domain is all real numbers. This is a continuous function that continues on just like sine did and goes from negative infinity to positive infinity. It continues its periodic behavior. The range, just like sine, is -1 to 1. We have minimums of -1. We have maximums of +1. So that's the range of our function. Cosine is an even function. Remember, even functions are defined to be functions that are symmetric about the y-axis. And it turns out that cosine is even. It is also a periodic function just like sine, and the period is 2 pi because of that unit circle. It has infinitely many x-intercepts, but instead of at intervals of pi along the x-axis, they happen at intervals of pi over 2 along that x-axis. There is only one y-intercept, and that is this point right here. It only crosses the y-axis in one point. Again, the maximum value is 1, the minimum value is -1. The amplitude, therefore, is 1, and the period is 2 pi. So we've already talked about the fact that the coefficient to the entire function, if we have a number in front of the entire function, that is going to affect our outputs. That is going to stretch, if that value is greater than 1, that is going to stretch those outputs, make them higher or make them lower. And the absolute value of that, here we can see on this graph that the amplitude is 2. So what was a maximum of 1 on the parent cosine function is now a maximum of 2. And what was a minimum of -1 on the parent cosine function is now a minimum of -2. So everything we learned about amplitude for the sine function still holds true for the cosine function. So let's graph this function. Let's start with the parent cosine function, We have zeros at pi over 2 and at 3 pi over 2. We have a maximum at 1, or a maximum of 1. We're going to have a minimum of -1, and we'll have another maximum up here at 2 pi. And it is a smooth continuous function that's just a little bit curvy. We don't have to be exact. We do recognize that it is a continuous function. So there's the parent cosine function, y equals the cosine of x. Not sure what happened there. We'll draw it back in there quickly. So it looks like that. We'll grab another color, and now we are going to stretch this function. We have now a maximum of 2 and a minimum of -2. So our zeros are the same. Our zeros have not changed. So we're still going to go down and intersect at pi over 2 and at 3 pi over 2. But now there is the graph of y equals 2 cosine of x. So that is a vertical stretch because that is a value, it's a coefficient to cosine of x, and it is a value greater than 1. So we can see here that if we had a value that was between 0 and 1, if this is the parent cosine function, this red function, that's the parent cosine function, and now if we have, oh, no, that's wrong, that's a period change. Sorry, I was talking about y equals 1/2 the cosine of x. Then what we would have is we would have our maximum be half that distance and our minimum be half that distance. So it would look like, so we would still have the same zeros, still going to go through the same zeros, but we would only go half the height for this function if we had an amplitude that was between 0 and 1. We will talk about, this is actually going to give us a period change here, so we will talk about this on another slide. So just like we did for sine, we're going to find the period for cosine exactly the same. We're going to look for the coefficient inside the parentheses, the coefficient to x, and we're going to divide 2 pi by that value, and that's going to give us a change in our period. So if the period changes, then cosine goes through what it normally does in 2 pi. Cosine's going to go through that much quicker. So if this is the parent cosine function, if we had something that made this value smaller than 2 pi, it would go through it quicker. If it made it larger than 2 pi, it would go through it slower. But that's going to affect our period. So here are the same formulas that I gave you in the last lesson concerning sine. They're not changed. It's the same for cosine as it is for sine. The amplitude is the coefficient to the entire function. The period is changed based on the coefficient to x. So now let's see if we can graph y equals 3 cosine of 2x. So let's start by graphing pieces of the parent. I can get these points to stay. We'll just graph this piece of the parent cosine function. So there's what the parent cosine function would look like, and it's going to continue go in this direction. So there's y equals the cosine of x. We'll get another color and we will graph y equals 3 cosine of x. So where we had a maximum of 1 and a minimum of -1, we'll have a maximum of 3 and a minimum of -3. So this function would look like so. So that's taking care of the amplitude. Now we're going to talk about taking care of the period. The period starts out as 2 pi. We have a coefficient of 2, or b is 2. So now the period is pi. So what this function did from 0 to pi, it's now going to do from 0 to pi over 2. So we're now going to have a minimum down here at pi over 2. And we'll have a 0 at pi over 4. So now this function is going to look like this. We're going to go very quickly down here, and we're going to have our minimum at pi over 2. So I'm just drawing a little piece of it, but you get the idea that that's what the period change does. Instead of it taking an entire 2 pi for cosine to get through its complete rotation or complete period, when we have that coefficient inside next to x that's 2, it's going to make it speed up and go through its entire rotation twice as fast. So that's what it would look like for an amplitude and period change. Now let's talk about a phase shift. Remember, we don't call it a horizontal shift when we're talking about trig functions. We call it a phase shift. So again, we'll draw the parent function. We have a 0 there. We have a minimum there. We could even draw this piece of it here. We're going to have a 0 here and a minimum there. And so the parent cosine function here would look like so. That piece would look like that, and this would look like this. So there is y equals the cosine of x. And now what we have going on here is every point is shifted to the right. Remember, that's to the right. Is shifted to the right pi over 2. So I'm going to take this point and pick it up and put it over here. And I'm going to take this point and pick it up and put it over here. And so I'm going to have my maximum here. I'll pick this up and move it over here. So now I just pick up this complete function and move it a distance of pi over 2. Let's see here, a distance of pi over 2 to the right. So it is a horizontal shift. That's all it is. It's a little clunky to keep up with because we're not necessarily used to our tick marks on the x-axis looking like angle measures, but it's still the same. It's the exact same thing that we did with sine when we moved it a distance of pi to the left. So you just look for those very interesting points on the graph, the maximums, the zeros, the minimums, and you move those whatever distance, whatever the phase shift is telling you to move them, and replot them there, and then just connect them in that little curvy fashion that you know cosine behaves like. So there's the parent cosine function and all the interesting information on it. So come to class next time and we'll practice graphing the parent cosine function and transformations on that.